This episode of Serverless Chats is sponsored by Lumigo. This week, Rebecca and I chat with Jonas Bonér about abstracting stateful serverless. This is Serverless Chats, episode number 112. Hi, everyone. I'm Jeremy Daly.
And I'm Rebecca Marshburn.
And this is Serverless Chats. Hey, Rebecca, how you doing?
Hey, I am really good. I'm just going to jump in without you asking me. My weekend was great. Thank you for asking.
You already know what I'm going to ask you.
A final wedding, and then I went camping in Yosemite with my dad during the fall equinox. And nice. What a stunning place. We did some backcountry hiking, slept in the woods for a number of days. I got really smelly. And, all in all, that just means it was a really great trip.
It sounds like it. Well,
how about you?
Well, I was going to say, speaking about smelly, I just started up my bowling league again. So
that'll do it.
Yeah, and now for people who are wondering, it's like a typical bowling league. Although it's candlepin bowling, so it's a very small balls, and you get three. If people know the rules of actual bowling, this is a very small subset that's like isolated to the Northeast and parts of Canada. I don't know why it's weird. But anyways, so I've been doing that, obviously continuing to do my soccer and all that other stuff. And then, of course, always, in my perpetual quest to try to find the perfect serverless abstraction.
Well, speaking of serverless abstractions, we have the perfect guest for that. And I'm wondering if you would want to introduce him.
I would love to. So our guest today is the CEO and founder at Lightbend. He's the creator of the Akka project, initiator and co-author of the Reactive Manifesto and Reactive Principles, and a Java champion. Jonas Bonér is with us. Hey, Jonas, thanks for joining us.
Thanks a lot. I'm happy to be here.
So let's start with some questions, first of all, about what is Lightbend, what does it do, what is the Akka project, and then let's get a quick overview of Akka Serverless, and then we can jump into some of the details.
Sure, that sounds good. So starting with Lightbend, then I suppose. Yeah, I founded the company about 10 years back around the open source project Akka. And back then, it actually started as a collaboration between me and Martin Odersky, the creator of the Scala programming language. And Akka was a project. We can talk more about that later, but it was built in Scala, and it had Scala and Java APIs. It's sort of a distributed middleware platform on the JVM. So it was, in Scala at the time, was pushing a lot hard, for concurrent programming, and it still, of course, is great. But they were doing a lot of work there, so it was natural to join forces and trying to sort of create the next platform on the JVM for tackling what we now call cloud, essentially. And it was like early days. It was not, cloud native wasn't really a thing, but we were really trying to build the best platform for multi-core and multi-node, so to speak, distributed systems. But it's been 10 years. We've been going through a lot of chapters along the way, so to speak, and adding capabilities to it. And the latest one is Akka Serverless, so that we can talk more about later as well. So.
Yeah, so with Akka Serverless, so one of the things, and there's been some good buzz about it, very interesting. I'm super interested in serverless abstractions. I really am, trying to find a way that we get more developers to build with serverless. So Akka Serverless talks a lot about stateful serverless, with this idea of getting rid of the database, completely abstracting that away. So can you explain a little bit more what stateful serverless means?
Sure. I mean, we've been going through a lot of incredible innovation, I think, in the serverless ecosystem in general the last 2-3 years, and it's adding more capabilities in almost every aspect of things, from all the way from infrastructure, things like Knative and KDI doing very cool stuff, and developer tools, including operational tools like observability and all the things, and we're starting to see more and more products, being able to be consumed in a serverless way, in a way. So I think it's clear that serverless is really revolutionary. I actually see serverless personally, as the future of the cloud. It is really the way we should build systems. We shouldn't have to, as developers, the infrastructure is so good. We have all these cloud vendors now doing amazing stuff. We shouldn't really have to care about the nitty-gritty details of operating all these servers and et cetera. So I really think that it's really the future. That said, I a couple of years ago, like 2-3 years ago, when I started getting super excited about serverless, I spent a lot of time talking to our clients, our existing Akka platform customers, and it was clear that a lot of things held them back for being able to move all of their bigger enterprise systems to the serverless experience. It was clear that stateless serverless, function as a service was and still is. I mean, it's a really, really good tool for a specific set of use cases, like a subset of everything you want to do. You can argue about how big. For some apps, it might be everything you need to do. For some, it's a smaller piece. Right. But it is clear that there was something missing in order to build essentially any app, general purpose type of applications, enterprise applications, and etc. And when we started thinking more about it, it was clear that most of the things, not all of it, but a big missing piece was how to tackle state, distributed state at scales, available state, etc. And the reason why we decided to try to tackle that challenge is that that's what we've been doing the last 10 years in Akka, and we have a lot of experience working with our Fortune 500 customers on trying to solve these problems. We were just thinking, is it possible to take these distributed system patterns, so to speak, the way how to manage state and sort of data in general, data in motion, data at rest, both these aspects of state, and sort of wrap that up or dress that up sort of in a serverless dress up, and that's sort of what led to like Stateful Serverless. I don't know if it's not really a great name because it sounds like it's replacing stateless serverless, but that's not at all the idea. The idea is just to add more tools to the toolbox. Right. Sometimes you need stateless, which Akka Serverless can absolutely do, and many other tools can do it. But our contribution is adding more tools to that toolbox around data, and data availability, state availability, and how to scale that, and making sure that it's always consistent, it's always correct, and you don't have to worry much about it. So I guess that's what we're sort of trying to bring to the picture, and many others as well. Stateful Serverless is starting to become more of a thing now than like 2-3 years ago when we started thinking about these things.
Yeah, and then go ahead. I didn't mean to cut you off.
No. I was just going to say we can talk more about these things in depth if you like, but this is sort of the overview.
Well, that's about what we're going to do. We're going to talk more about it. Earlier in an article, I think just a couple months ago, actually, you called it a quantum leap of value, right? When you get to add stateful serverless to pre-existing tools that do a lot of stateless serverless. So I'm wondering, you talk about these challenges, right? You say the next quantum leap of value generated by the cloud will come when serverless is able to address the full gamut of applications required to run a business. And so I'm wondering, with those companies that you've worked with, you said you've worked with a lot of Fortune 500 companies and really people all over the map. Where and how do you see them experiencing some of those challenges today? And then what did those challenges that they had, how did it inform how you built Akka Serverless?
Yeah, that's a great question. I don't know if we should first talk about what Akka is and why people gravitate towards that. Does that
probably
make sense?
We should probably add that context.
What Akka is really trying to do, and is to through building a platform on top of what I think is one of the best abstractions, actually the best abstraction for distributed systems, the actor model. The actor model, is like a model since the 70s. It's been used, in very successful in many different, more specific situations. Like Erlang, for example, is like this obscure language that Ericsson have been using to build, extremely reliable telecom switches, for example. And then it's starting to creep up. Now you have Elixir is starting to become more, and there are web frameworks on top of that. So it's starting to become a little bit more mainstream, a little bit here and there. But when I started Akka, the actor model wasn't really that much known. It was like not 2009, so it's like 12 years back. But that was the best foundation I could have for building a platform for distributed systems as well as concurrent systems. Because the way I view it, they are essentially the two sides of the same coin. They have the same challenges if you want to scale out to multiple cores, as well as multiple nodes, as well as multiple data centers. So all the way from like inside, so distributed systems in a way, if I may get a little bit geeky, within the actual server. Because if you have multiple cores, you essentially have a distributed system within the server, all the way up to the larger scale. The distributed, multiple data centers, and having a single abstraction, the actors and message passing, and sort of that encapsulates state and behavior. And I'll get back to that, why I think that matters in serverless later. But having that sort of abstraction and working with message passing as a first class thing, including having a really good way of managing failures that is very honest, instead of trying to hide things like many distributed systems, like EGBs and core by, many try to sort of hide things. But Akka and the actor model really tries to make it explicit and making it very honest in a way, to the challenges that we have when we embark on building distributed systems. So you have the only complexity you have in a way is like the actual essential complexity and no accidental complexity, if that makes sense. So we built this platform around these premises, folded in streaming quite soon afterwards, to tackle like fast data type of problems. And it was clear that a lot of the customers that went sort of gravitated to us were like these really large Fortune 500 companies that have systems that can never ever stop. They had immense levels of scalability, and which was not actually honestly that common, back in 2011, 2012 when we started. But with the emerging of the cloud, it has really become extremely common. Now, when you deploy apps to the cloud, you actually don't know if it's going to be, quite rapidly hit with like, hundreds of thousands of requests if you're successful, and you have the ability of scaling out. But like 10 years back, having this like this farm of servers on premise was quite expensive and quite. It's like more for the bigger systems or bigger type of bigger customers, I would say. But so what we really try to do is since it's like the needs have become more and more common, to actually stay always available, never ever crash, to gracefully scale out and up and down, for efficiency reasons, etc. It's been clear that that the platform we built for Akka was actually not just for the bigger guys like Starbucks and HP and some of the other systems, ING, Capital One, some of our larger customers. But it's actually starting to become something that everyone values, and it's important for everyone when they deploy to the cloud. So it's been also clear that even our Akka platform is now actually deployed mainly to the cloud. We have like 75% of our customers actually building things for the cloud. But they're still struggling, honestly, because they're struggling with the infrastructure of the cloud, and they're struggling with like pulling all the pieces together and operating it and all of these things. Because stitching it together, even though you have great tools, and I really believe the Akka platform is a great platform to doing that, it's still challenging. And that's the reason, why we sort of try to move all of this great stuff, all the scalability and availability and performance, extremely low latency, out into the cloud in a sort of serverless dress up, to make it available for everyone, more or less, in a sort of pay-as-you-go way.
Yeah, and I really love how you said sort of this honesty of distributed, or that distributed systems need to be honest, right? So you get all these companies that start moving to distributed systems, and they have to accept this change from reliability to resiliency, right? Where they now have to just embrace failure as one of those things that's going to happen. And I love that term, just keeping it honest, right? Like don't hide things. Like if a system's down, react to it, find a way to, have a resilient way to deal with it, but don't just, try to keep everything up 100%, because that is never going to happen in a distributed system.
Exactly. And where I think that pays off most is around how you deal with failure, because
right.
if you've optimized for your happy path, so to speak, where everything is working well, it's like beautiful abstraction, everything just works. But as soon as things start to fall apart, if your abstraction doesn't expose failure, it doesn't have a way to working with failure, I mean, it's almost game over. But instead of, if you're sort of, I'm sometimes talk about it as like embracing the network and all the sort of intricacies and all the shortcomings of the network. Right. If you bring that into the programming model, sure, it becomes a little bit more complex. It does, but it's essential complexity, because having that under your fingertips, means that when things go south, you have control over it, and you can actually manage it and sort of manage failure, as part of the programming model. So that has served us really well, and for us, that has served our customers extremely well. So.
Right. So you talked a lot about scalability, or being able to scale out gracefully, and one of the ways that you do that with Akka Serverless is by deploying on top of Kubernetes, right? Mm-hmm. So could you explain a little bit more about like what is the scaling characteristics of this, and how is that sort of managed, for the user?
Yeah. So this is. We have sort of an unusual way of dealing with scalability, since we actually trying to manage distributed state, and bringing in state, and we can talk about why that matters, later. I don't know if we can talk about why it matters.
You can talk about it right now.
I think the why is pretty meaty.
Yeah, the why is important. Right?
Yeah, let's go with the why.
The how, I was just thinking. I think that the reason why I think it matters is that everyone knows that there's a ton of value in data today. Most of the value is actually in data, and a lot around is actually getting intelligence out of data quickly, and when applications are deployed onto the cloud, and you have thousands of extremely impatient users, users usually expect to get intelligent answers back quickly. That means that that the systems need to be able to process data almost like flies by, in quotes. Sort of just grab it on the fly, do intelligent things with it. Sometimes like merging, transforming, and enhancing data streams can be, but regardless of how you do it, like mine value out of data in real time, and that's really, really hard to do if you always need to put your data somewhere else. If you always need to if you sort of change it, you always need to store it down in the database somewhere else, often with a network, in between. Sometimes there's even, there might be even in another data center. But there's a lot of latency over to putting data somewhere else, and when you then need it, you need to go and fetch it and pull it back into context where it's needed. So here data locality is extremely important. If your data is always right where it needs to be whenever you need it, wherever you happen to be, then things are good, because you can just use it, and and there's actually zero latency then. That's not always the case. There might be some loading that needs to be done, and so on, of course, and there might be sort of migration of components, and then there might have to be rehydrated and things like that. But in most of the cases, if you have an efficient and good platform that understands state, it can actually make sure that your data is always where it needs to be whenever you need it, even before you need it, so to speak. It's always right in process. It's always right there next to the processing. And this is really what we're trying to do. And I think this is one of the key things about, stateful serverless, like bringing state into the application, into what we, entities. We talk about entities instead of just having sort of snippets of code, so to speak, which it's a really nice thing. And I like that people, the way people talk about it in serverless, because it points towards simplicity, but sometimes perhaps too much simplicity, because snippets of code doesn't really have semantics around state. It doesn't have any semantics around what does your data model look like, and how, and here I think it's often meant, or sometimes at least, I shouldn't be too arrogant, but sometimes, it's useful to think about it as in terms of entities. I mean, entities meaning having a data and data model, some sort of schema and understandability around what data means, what semantics are, together paired with the processing. And if one of these entities need to be migrated, it does it as a whole. State and processing moves around with it, and this can give you a really good foundation for extreme low latency, especially if you start thinking about moving things out to the edges.
Right.
And I'm not talking about actual edge here, like the actual devices. That's the ultimate edge, but just sort of start leveraging many like points of presences, having sort of edge clusters in a way,
right,
and pushing things out to where the users are. Then it's extremely useful to have the state come along with the processing, and being able to do everything that's needed almost out there. Sometimes there might be some fancy query or some fancy computation that you don't have all your data for, and then you fall back to the more central cloud, or you might bring in state. But let's say, like, if you can do 80% of all the processing with state you have right there, then you can serve a lot of very new cool use cases, like consumer and industrial IoT, for example, and real-time financial services, like factory automation, telemedicine, and like internet-based gaming. A lot of these cool things that have really low latency guarantees can then be sort of used in a serverless dress-up. So this is how I'm thinking about the problem and what we're trying to bring to the picture. Now you sort of asked how we do scaling and things like that, and here is where things become a little bit different, or a little bit more complex, because if all you have is stateless services, then it's very easy to scale. You can like in 2 seconds bring up 1,000 instances, having a load balancer just redirects everything to them, and then into all these new instances, have them run for a while, and then you can just kill them all, and it's just fine, because state is somewhere else. So that's a benefit of stateless scaling. You have like, scaling is almost free in a way.
Right.
When you have state, it's not that easy, because it's more complex, in how you manage it, but it's also a lot more expensive to scale out stateful components, because then you need to replicate the state, and state goes along with the processing, as I said. So we can't, for example, use vanilla Knative autoscaler, because it's simply too aggressive for stateful needs. It's not really meant to be used with stateful components like this. And we actually tried for a while, and we worked with the Knative team, and they're extremely open, but everyone's busy on so it wasn't like top of their priority back in the day. So we actually backed out and implemented our own autoscaler that is more understands state, is less aggressive, and try to be more smart. Mm-hmm. But the heavy lifting is actually not done by that autoscaler that just spins up instances, but it's actually done by Akka and the module in Akka called Akka Cluster, where we actually. Are you familiar with DynamoDB?
Absolutely.
And React and Cassandra? They all use this model of a node ring. So they put out all their sort of all the servers in sort of node ring, and they have intelligent replication in how things can be replicated across the cluster. We use exactly those algorithms in Akka Cluster. So we sort of lay out all your servers in an Akka Cluster node ring, so to speak, and we use intelligent replication across like shards across. So we actually shard your whole data set, And of course, we make sure that a shard normally spans multiple nodes, so you have fallback. It can span 3, 5, 7 nodes. But we sort of shard it out across the whole cluster, and that means that when you create an entity, then it's actually placed on the shard where the data lives, including will be run there in terms of processing. And let's say that you resize the cluster because there's there's a lot more load here. Then the autoscaler will make sure that this whole node ring is like sort of scaled up, and then there will be more nodes and available power to be used. And then we sort of starting to reallocate these shards across this node ring until you have some sort of even distribution. And all this is happening under the hood. Same thing, of course, is equally important if you want to scale down. Like if you don't have that much load, then the cluster will detect that and automatically resize itself so you can conserve resources, money and energy and all of these things. So it is sort of a dual approach. We have a cluster doing all this cluster sharding and intelligent placing of functions, physical placing, so you get co-location, and then we have the little bit more intelligent, or I wouldn't say more intelligent, but aware of state, load balancer that works in concert with that.
Right.
So
yeah. Yeah, so I'm curious about the intelligent you said the intelligent routing of data, also sort of this intelligent placement of functions, co-location of functions. So is that something that the system does where it says, okay, these 5 functions or whatever, these are often communicating with one another somehow, they use similar state, maybe the entity design pattern really helps because you can say these functions access this type of entity, so I only have to replicate so much data to these nodes or so forth. I mean, is that sort of the thing you're doing, or is it, I mean, is that the type of optimization? Is that and if not, is that somewhere you want to go?
Yeah, it's both. I say we do some of that, but we have a lot of work. It's a never-ending story in terms of work here. How we can make it more and more intelligent. Yes and no. I think there's definitely a lot of interesting optimizations we can do here. But what we have is actually what our customers use in the Akka platform on premise and in the cloud, and have been used the last 10 years, and it's working quite well. So, but we're never done, of course.
Of course. Hi, everyone. I want to take a minute to thank our sponsor, Lumigo. We've talked a lot about observability on this podcast, and if you've listened to any of those episodes, then you know that it can be difficult to achieve serverless observability with traditional approaches. Though serverless comes with many opportunities and advantages, it also has some unique issues that some tools just aren't able to address, and those issues really need something meant for serverless environments. That's where Lumigo comes in. As a serverless-first monitoring platform, Lumigo lets developers quickly and easily find and fix errors and performance issues while also giving you an end-to-end view of the entire transaction across services and functions. All of the debugging information you need is conveniently in one place, and you're able to set up alerts so that you know what's happening and how it might affect the user experience. Lumigo also knows how to play nice with your existing toolchain, enabling you to send alerts to email, Slack, Microsoft Teams, Opsgenie, and more, and can also create tickets in Jira straight from the issues page. Thanks to their automatic distributed tracing, it only takes 4 clicks to set up Lumigo with no manual code changes necessary. Sign up for free at lumigo.io.
Okay, so I think, correct me if I'm wrong, that we know 3 things about how Akka Serverless scales, right? And like how this data persists and how it scales. 1 is Akka Serverless is built on Akka. 2 is it uses a high performance distributed database for data persistence. And then 3, and this is the one that I saved the best for last, that might be a leading hint into the question that I'm about to ask you, is Akka Serverless leverages Kubernetes under the covers to handle container orchestration at scale. I'm wondering if, using Kubernetes to power stateful serverless applications, should we pull the thread around like that purist vernacular, right? And like, can you have Kubernetes and serverless in the same sentence? And what I'm wondering if you've had conversations around that, around using Kubernetes for serverless applications, and whether or not people have wanted to antagonize that idea.
Yeah, I mean, we do it very successfully. I mean, Kubernetes is really serving us extremely well, and we've been trying to get in. We actually 2 times we ported over. We started bringing in all the good stuff done with Knative, that sits on top of Kubernetes. If not everyone knows, it hasn't really been there, and it's not the Knative team's fault, I have to say. They've been extremely open and would love us to help out and are super interested in the ideas that we have. It's just that there's just so many things you can do now, and we've been really focused on shipping this platform. But I think I'm pretty certain that we will get back to Knative and start leveraging that more and more, along the way, because there's some really interesting work being done there. So in short, we've been extremely happy running on Kubernetes, and that also makes it very easy to port. Now we're running on GCP only because you need to start somewhere, but we are currently working on porting it over to become multi-cloud. And perhaps even being able to wrap it out in private clouds, and running on generic sort of infrastructure, if that makes sense. It makes that easier, of course.
So does that sort of like dovetail into that idea of essential complexity versus accidental complexity, in terms of when you evaluate something, you're like, okay, is this essential or accidental? And you're like, Kubernetes is actually an essential. Well, I would say it's less complex, but that's something you're choosing so that you can have the essentialness rather than the accidentalness.
Yeah, I mean, of course, if you really want to optimize everything from the ground up, if I had like unlimited amount of time, it would be fun to build something without Kubernetes. Being in control of everything from the metal all the way up. But I don't have. We're all have a limited time, and Kubernetes has done an amazing job abstracting a lot of these complexities. Same thing as Akka's really done a great job, in my opinion, if I may say. In abstracting, some of the programming model and application level complexities in terms of in distributed systems. So I think building Akka Serverless on top of these two, Kubernetes, and then Akka on top, means that Akka Serverless itself is actually not that much code, to be honest. Comparatively, it's mainly evolves around bringing all the pieces together, providing SDKs for any language. We haven't talked about that, but that's a given. That Akka Serverless is not Java, Scala only, just because Akka is it. We provide that. We have SDKs for almost any language that is popular out there. JavaScript, TypeScript, Python, C#, Rust. There's a long list. Go, of course. There's a long list of So most of the work have been done in two areas. Is bringing everything together in this sidecar architecture. The proxy architecture sitting next to your app, and the SDKs exposing that to the outside users. So.
Yeah. And I think you're right. I mean, the abstraction piece of it is where Kubernetes comes in, where it's like there's all that complexity of the cloud. Kubernetes adds a ton of complexity in and of itself, just managing it, but it reduces that complexity then when you implement it, and then you build things like Knative or OpenFast or any of these other things that then run on top of that are another level of abstraction. And again, from a serverless purist standpoint, if you got to manage the Kubernetes infrastructure yourself, it's probably not as serverless as you would like it to be. But when someone else is managing that, then all of a sudden it sort of changes. So totally get the abstraction thing there, and agree with you. I'm just curious about abstractions in general and how you think Akka Serverless fits into this sort of paradigm where, you talk a lot about the limitations it removes, right? And this is always something we try to do, like, okay, well, now you have state in your serverless applications. That's great. So now you can build other types of applications. But I'm curious, looking at it from the other side. I've built a lot of abstractions in my day. I've used a lot of abstractions, and abstractions inherently also add limitations sometimes. So are there limitations that this adds? I mean, whether it's operationally when somebody has to manage this, or maybe even just the developer workflow? Or does your abstraction add any limitations? Not necessarily that they're bad things. Sometimes limitations can be called constraints, which are sometimes good. But I'm just curious if that's something that you've addressed or you think about.
Absolutely. That's a great question, and one that I've been thinking a lot about. That's important to me, and I think that Akka Serverless is the opposite of Akka in a way when it comes to that. Akka is like this perfect toolbox for the distributed system geek. You can do anything you want, anything under the sun. Everything is there, and it composes nicely. But it also means that it can be overwhelming to a lot of users building these type of systems. That's why we sort of reach for a more constrained, if that makes it, or limited, if that's more guardrailed approach. Where you can actually you can't do everything that you can, and that some people might want to do. But we settled on a set of abstractions that we think can solve most of the use cases, but in a way that simplifies things, like having one way of doing things instead of 5, and having a specific set of ways of looking at state. We haven't talked about what it looks like in terms of actually building something with Akka Serverless, but we have the notion of state models. We now have sort of 3 state models. We're probably going to add more in the future, and they all have different semantics. They all have different guarantees, and because I don't believe in one size fits all. If all you have is a SQL database, then you need to pay the price of strong consistency always. Even if you don't need that, it's quite wasteful. But that's the reason why almost all non-trivial systems out there, enterprise systems, usually use a lot of different databases. You have a NoSQL database, and you have like a SQL database. You have a graph database, etc. Right? Because there's really no size fits all. And I think that since we have state first class in the programming model, having a way to define your domain state, sort of just annotate more or less declaratively. We do that in protobuf. We haven't talked about that, but you sort of define a schema for your domain state. Here you can sort of annotate simply how that state should be viewed, and what kind of semantics it should have, and ultimately that will affect how it's replicated, how it's stored, what consistency guarantees it has. So it's like a little bit of guarantees or consistency a la carte in a way, and that's of course liberating, but you only have 3. So yes, I mean we might add more, but you have to work with what you have still. And when it comes to processing, you have the function essentially. That's essentially the way you look at it. And you have events in and events out. So that's all. And of course, we have also gRPC, so you make a gRPC call out, but it's still fairly limited. But it turned out to be great. This function abstraction, is one of the reasons why I think serverless has really taken off, because it's so simple. You have state in, and so you have event in and event out. And the only thing really, if you look at it from that perspective, that we have added is that instead of just having event in, and you don't need to care about how the event ended up in your function, and then you emit the event when you're done, we view state the same. So you have a state coming into the function injected whenever you need it, and when you're done, you just emit it. So there's a duality between events and state in our model,
right?
Which which simplifies things, but is also quite constraining in a way, because your state is only handed to you, and you can only emit it. You can't do anything else. But I believe that can be liberating when it comes to cloud, because there's so many things that are so complex. And anyway,
right.
So yeah, you at the top of our conversation, right? You're like, I do think that serverless is the future, and I'm actually going to reference the article because I've referenced this twice, and so I want to make sure that Sarah Schlattauer, I think is how you say her name, gets credit for an article that helped me understand a bit about Akka Serverless. With her interview with you from Jack's Enter. And so credit to you and her for that conversation and for inspiring this next question. But you talk a bit about Akka versus AWS Lambda, and it's like, is this the elephant in the room? And basically you say, we see Akka Serverless as bringing the possibilities of the incredible serverless paradigm to a much broader set of developers who until now have not been able to use serverless for building high performance business critical applications. And so I'm wondering if you can walk us through a few examples of high performance business critical applications that do require state, where like this now, Akka Serverless now allows you to do this, so that maybe it opens the minds of someone who's listening being like, oh yeah, that is exactly the way I would want to use that. And now I see where that's going.
Okay, sure. I mean, it's of course a complex question that ideally I would like to have a whiteboard or something, but to walk you through. But in just superficially, and I really think that one for example, really excellent use case for this, I believe, is the digital twin pattern in IoT, where you sort of want to map a some sort of device in the cloud, like a physical representation of a device in the cloud, and having that because the devices are naturally sort of bringing together state and processing. So it's a very natural thing to do, to be able to map this sort of entity that we talked about. That sort of but both has always, regardless of where they run, always have their state with them as they move around, and having that sort of virtual entity mapping to a physical device in the cloud. I think that's a use case that fits that world perfectly, and often that is paired with some sort of real-time streaming. You have sort of streams between these two, and streams between these devices and things like that, and having the data always in process then is of course ensures that you're able to do this sort of more limited, I have to say, but often sufficient analysis on the fly, so to speak, without having to go back to some sort of backend, running Spark or Flink or like Hadoop or whatever that use like the mining offline, which also has its place, but being able to actually quickly get intelligent answers back and is something that matters a lot in these type of IoT devices. You see some of the same needs when it comes to like real-time financial services, and here I'm drawing a lot of experience from where people have used Akka now in the cloud, and our goal is now to actually enable all of our, ideally all, probably not actually all, but most, let's say, of our customers to eventually be able to move to Akka Serverless in the cloud with their full complete application and not losing much, instead of gaining this great programming model and being able to have teams use whatever language they like, etc. So it's of course a lot more to be said, but I hope it made some sense.
Yeah, illustrative. Thank you.
So I'm curious too, kind of following up with that question from Rebecca. So a bunch of these new applications, perfect use cases. You mentioned, the things like the twin pattern and some of those sort of things. I think that makes a lot of sense. I do think, though, that there are developers out there who have experience with the cloud, whether it's Azure or GCP or AWS. And they've been able to build a lot of these applications, but I think we know this is the strife, the strife we go through, the constant striving for trying to build a better abstraction. I do think that Akka Serverless and other abstractions, even like Nimbella and some of these other ones, they do open it up to a broader set of developers, like you said. I'm curious who those developers are. Do you think those are people that are just not into the cloud yet, or do you think these are cloud people that just want to make it easier? Or is there some classification of developer that you think this opens up to, or is this just a new type of developer? Is this just like a new cloud developer, and we should expect stateful serverless to just be a thing?
Yeah, I mean, first I'd like to talk about the sort of the composed thing of stateful and stateless serverless. Same thing as people you've been using building stateless apps with Akka. That's fine, and we provide a lot of value there. So it's not either or. But right. I just want to stress that it's like adding more tools into your tool chain. But that said, I think it can actually open up for more of this, classic enterprise backend developers, the people that are on the JVM, perhaps using Spring and Oracle and these things, and they feel reluctant to move to the cloud. They don't think it has everything they need. They're super excited about serverless, but they know that they need more than what is has been offered up till now. I think it can open the door for more average developers, perhaps not the early adopters, the bleeding edge developers they can do everything with anything, and as you said, people have built all of these systems probably using Lambda and using stateless serverless, and sometimes with some with some really clever engineering, but we just but in my opinion, you very often end up with suboptimal and not as efficient systems that it can be, because if you try to shoehorn something that's not intended for it into your solution, then you miss out on some things. And I believe that when it comes to actual state, it's better to use abstractions and tools that are meant for addressing that. So it's really like in the name of efficiency and in the name of using the best tool for the job. But absolutely, I think it can open up for more people moving to this great new serverless experience, and it really deserves that, in my opinion. It should really be the way we consume the cloud, as I said in the beginning. Hopefully, in five years, that this is the way we build systems and put the hard stuff on companies like Lightbender or Microsoft and others to do the heavy lifting and making sure things are up.
Right.
and meet your SLAs.
So we're running out of time, and I want to get to two more things.
This happened fast.
It did happen fast. This was an awesome conversation. And I know we didn't get into a lot of the technical details or a lot of how to build an application on Akka Serverless and so forth, but we're going to put all that information in the show notes, all the links, so you can go and you can check that out. But while we've got you here, what was it, 8 years ago or more? It was 2014. So how many years ago is that came to
math,
the math?
Jeremy.
Math is so hard. Yeah, math is hard. Anyways, you wrote this thing and initiated this thing called the Reactive Manifesto. And you laid out these really cool sort of and then you also have this whole reactive principles thing that you do, and we'll put all this stuff in the show notes. But I thought the reactive systems, or the idea of what a reactive system was and what was in this manifesto, was this idea of being responsive, resilient, elastic, and message-driven. Now, this is 2014, so this is before Lambda, this is before serverless is even really sort of a thing. And I reading that document, it seems like a precursor, the spec for building serverless applications, right? Like you're ahead of your time. But I'm really curious, is that something that you felt that the serverless movement and this idea of building message-driven distributed systems and all that kind of stuff, again, Lambda just reacting to an event, and of course, obviously the other fast services that do that. How do you sort of see that? Was that the vision you had way back then when you were writing that document?
And I wish I could say yes, I saw this serverless coming. But then I probably would have invented it, like instead of writing that document. It's not that simple. It's always easier to put one and one together when you look back.
Right.
harder to predict the future. But sure, halfway yes as well, because I knew where I wanted the industry to go when it comes to tackling these new challenges, when building things for the upcoming cloud, building things for the great infrastructure Amazon started to provide, and others as well, and the reason for writing it was that it was when I was out talking to a lot of people. Akka's been around for about 5 years back then, and it was. People didn't really understand why and how they should conceptualize about these new type of systems. And so what I tried to do is distill it down to some core principles and make it easier to grasp, the gist of it. It's of course very superficial in a way, and that's the reason why I added this document around reactive principles. It goes a little bit more into depth, trying to explain what reactive systems is all about. But anyway, you're not really trying to give a common vocabulary, having one way of looking at it, so people can communicate and talk about the systems in the same way. And also, a little bit like call for arms. This is what we have to do as an industry. This is where we're going. We better get prepared and join forces on trying to invent this future, as like Alan Kay would say. So it's that's really what it was all about. And I wish I would have come up with the Lambda serverless experience. I didn't, but that sort of followed these ideas, I suppose. While the reactive systems is more like the groundwork on how the system should work and how we should design these type of systems.
Well, I'm gonna give you more credit than you give yourself, because I do think that it was very forward looking, and I would be surprised if that document wasn't brought up in some of those early planning meetings.
And you're actually going to get a second chance right now, because it is certainly hard to predict the future, but we often ask a lot of our guests to say, like, hey, where do you see serverless in 5 years? But we don't usually have guests that are actively trying to shape that future of serverless. And so if we were going to predict the future, and perhaps you're going to write another manifesto about what's coming, 2 questions. Where do you think serverless is going? And where do you want it to go? Are they aligned?
Yeah, I have 2 passions, and I think they are aligned. I think we're going there, and I think we have to go there. And the first one is around the user experience. Even though serverless was really groundbreaking when it comes to that. Of course, more has to be done around the user experience and the whole tool chain, from developer tools through the CI tools, staging, all the way up, and also around the programming models. That's also part of the user experience, and how you actually reason about these type of systems. A lot of interesting work is being done there, but I think more work need to be done, and that's a place where we're really trying to think hard what it would mean. I think that's will sort of make it or break it for serverless, unless we make it super accessible. It already is, but I think we can do even better. And then everyone will not start using it, which I think it deserves. So there's of course more to say, but off to the next one that I think is equally important for me, at least. Perhaps, and it might be a little bit more early days, but that is the move to the edge. And how this the new type of infrastructure we're getting, things like 5G, for example, with the vision of having like hundreds of millions of points of presences, even now, essentially in your backyard, where you can have local groups communicating a little bit more offline, and having all this super optimization that can be done with 5G. Being able to push serverless up in that realm, and having hybrid solutions, because it won't just happen overnight.
Right.
We'll still have old cloud infrastructure, old in quotes, but traditional cloud infrastructure that want to communicate with these edge clusters and do it efficiently. And how do you program for that? I actually have to you mentioned that there is a very interesting small working group most people perhaps don't know about, that I've been happy to be invited, but it was one of my former colleagues, Roland Kuhn, that created this working group around what he calls local first software, where which is also goes a little bit hand in hand with this, but it comes from the other view. What would it mean to build systems where local is the default, and then you can sort of, if needed, if things start to fail, or if you have incomplete data, then call back to the cloud. So it inverses the problem in a way, and where things can go offline and function very, very well off the grid, so to speak, or offline with no connection back to the back end. And I think having great developer experience, the great developer experience that serverless has, bringing all of these cool things together for the future of how we build systems. I think it's super exciting. I'm thinking a little about that now, and Akka Serverless, can absolutely go in that direction, but there's just so many hours in the day, so we haven't done much interesting work to talk about. But that's a lot where I spend my time thinking about, at least.
There are only so many hours in the day. And yes, I totally agree with you. Accessibility is a huge thing. Edge computing is going to be huge. Like you said, that offline and that sync pattern. And what is the abstraction? How do developers do that without it being ridiculously confusing, that you've got data at 3 different levels here and you've got syncing between all those different nodes and so forth. Super exciting stuff. And I am so happy that we have people like you in the serverless community that are pushing for this type of stuff and trying to make these things better. And it was absolutely awesome having you as a guest, Jonas. So if people want to find out more about you, they want to find out more about Akka Serverless and the other things you're working on, all that stuff, how do they do that?
Yeah, if you want to find out more about me, you can go to my website, jonasbonér.com. I don't update it that frequently, so you probably shouldn't go there. But anyway, since you asked,
great plug, Jonas.
If you want to know more about Akka Serverless, go to akkaserverless.com. Akka, by the way, is spelled A-K-K-A with 2 Ks. So that's a bit weird, but go to akkaserverless.com, and want to know more about Lightbend and what we do there, you go to lightbend.com. So lightbend.com.
Awesome.
Akka is at akka.io. So and all these things are cross-linked more or less. So I think you can find your way to whatever you find interesting.
Right.
And then they can find you on social, right? Where will they find you on social?
Sure. J Bonér, J-B-O-N-E-R. On Twitter.
Beautiful.
Feel free to reach out. I'd love to know what everyone thinks about this, and both, if you agree, and even more interesting if you disagree. Right. Because that's usually where good ideas come.
Get the best feedback that way. All right. Well, we will put all of the stuff in the show notes, so you'll have all those links in there. People can find them there. Thanks again, Jonas.
Thank you so much.
Thank you so much for having me on the show. I'm honored to be. I really enjoy your show. So I'm really happy to be able to ramble about things I find interesting. So I've enjoyed the conversation. Have a great day.
You too.
And that's this week's Serverless Chat. Rebecca and I want to give a huge thank you to Jonas Bonér for being our guest this week, and to our sponsor, Lumigo. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/112. For more Serverless Chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with Rebecca on Twitter at Becca Odelay and me at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining us, and we look forward to chatting with all of you again next week.